טוב, אז קודם כל שלום. כמו שמורן אמר, אני רני, אני טק ליד במחלקת הדאטה. וגם כמו שהוא הזכיר, ההרצאה תהיה באנגלית, כי מקליטים את זה לפיידאטה כזה עולמי. חוץ מזה, כחלק מזה, שאלות בסוף. אני מבטיח שמה שלא נספיק תוך כדי המצגת, אני גם מסתובב פה וכזה תפסו אותי, ולא יהיו לאנשים שאלות כאילו, אם מישהו עדיין מעניין אותו משהו, זה יענה עד סוף הערב. And with that, okay, so I'll be talking about how to create an ad pipeline completely from off-the-shelf tools. The idea is sort of different from a lot of different talks. I'm not going to be talking about some crazy cutting-edge technology, okay? It's not some secret, super competitive algorithm that we worked on here. We have a few of those, but obviously algo trading, so it's secret. The point of this talk is kind of the opposite direction, okay? It's how you can offload by using off-the-shelf tools, how you can offload a very big part of the challenge, okay? And then focus on the things that you really find interesting, okay? The use case will be from the world of online ads. Obviously, you aren't all from the world of online ads, but I think focusing on what you can offload and seeing all the new tools that are now at our fingertips could be useful for anyone from different fields as well. So in general, focusing in, right? The idea is instead of working your way at reinventing the wheel, use power tools. They're already there, they're free, they're online. Enjoy, okay? And not only will I be talking about off-the-shelf tools, I'll be talking about how to do it in 34 lines of them, okay? This isn't like one line that's actually a paragraph. These are actually simple, super simple code lines that will allow you to use these amazing new tools. The examples will be from the world of Google Cloud, but all the big providers have similar tools. They're very easy to use. One more note, this talk, simultaneous with this talk, we've also put up a blog post with a little more of the details. So the code is actually there. So if you actually want to dive into the code of what we did or read the articles that it's based on, it's all there, which sort of allows me to run over the fun stuff. With that out of the way, let's talk a little about the world of online ads because it's the environment we work in, okay? So Moran gave you guys a bit of a background of how RPLI fits in, but in general, for those of you who haven't been following for the last 20 years, we like the internet free, right? We like lots of videos, we like games, we like new content, and we don't want to pay for it. We watch ads instead, and if those ads can be tuned to us and actually matter for us, actually things we're looking for, even better, okay? So the old world used to work in a very simple way, right? For anyone who watched Mad Men, some advertiser, right? Snickers in this case would approach some publisher and say, listen, I want to place ads on your website, okay? That was great. People in suits got lots of fun meetings out of it. Unfortunately, these days there's lots of different advertisers and lots of different publishers, okay? And the advertisers have specific requests. For example, we only want users in the morning for the sugar rush or something like that, right? Or we only want young people or old people or anything else similar, okay? So instead of managing it point to point like they used to, which gave everyone a headache, we put an auction house in the middle, okay? So all the publishers pool their inventory here, right? And then at any given moment, the advertisers say, I'm willing to pay $1 for it or $5, and whoever bids the most gets to place their ad. And I'll dive into a specific use case. So for example, I go to Sky Sports, right? And I'm looking at a soccer game. Okay, now behind the scenes, what actually happens is that Sky Sports approaches the ad exchange, the bidding house, in this case, Google Ads, and says, listen, I have an ad to place right here, okay? And then the ad exchange approaches all the different potential advertisers. RPLI, in this case, is an intermediary. We bid for someone. Okay, and RPLI says, you know what? We'll put Snickers there for $1.15. Okay, and all the other people in the background bid. And if we offered the most money, the person sees Snickers. Okay, now one thing to know is different companies can take different parts of the pipeline. Okay, so some companies, for example, will take, given a bunch of like a portfolio of ads from Snickers and only bid on them. At RPLI, we also make the creatives and alter them, and that's also part of what I'm going to be talking about. So we actually have a lot of the chain, okay? We're also the algorithmic part of figuring out how much and when, and also what we should actually be placing, okay? The thing is, this is one example, right? But the internet is huge, like really, really huge, okay? Because what I showed, also what I showed happens in 100 milliseconds, so it has to happen super fast, okay? So the internet is huge, right? And when I say huge, we're talking, sometimes we have seconds where we have 2 million pings to our server saying we have an ad for someone to place, okay? Which is a lot, okay? It's, our company has collected over 27 petabytes of information, which if you compare it to Fortune 500 companies, sometimes they have under 1 petabyte, okay? It's crazy amounts of data. We need insane amounts of memory because we have to handle all these requests and bid on them in real time. Luckily for me, I'm a data scientist, and I don't care, right? We have the R&D department. They're super smart. They can handle things at massive scales. I get to play around with my data. Okay? Now, as far as I'm concerned, it's a bunch of data points. It's, do people buy in the morning or in the evening? What kind of chocolates do they like? At which hours of the day? Do they like them more towards the holidays or after the holidays? And the reason I want to focus on 34 lines of code is so I can focus on my candy while the pipeline works and the machines can work in the background. Okay? So, like I said in the beginning, the idea is these are the amazing new tools that allow you to focus on the creative challenges, the algorithmic challenges, the challenges that give you an advantage over your competitors, so you can focus on the fun stuff, right? Cool. So, ad pipelines. Let's recap a bit, okay? Things that make a good ad pipeline, number one, is content. I need a lot of different images so I can place lots of different ads for lots of different people. And I need pricing, right? Because if I'm offering a quarter of a cent for an ad, and other people are offering $1, I'll never show my ads, and the creative department's amazing work will go to waste. All right? And if I'm offering $1 million, right, so great, I'll show a lot of ads, but I'll lose a lot of money. So that won't be fun. So in general, the components are create a lot of ads, right, lots of different content, figuring out how much it's worth, how much money I should be placing on the bid. If I have new content, figuring out when to show it and how much. Okay, and monitoring and improving. Okay, figuring out what I'm doing right, what I'm doing wrong, how to improve it, and when. Amazing. So down to the details. The first step, content generation, right? So I need large quantities because I have different advertisers. I need it to be dynamic and fresh, constantly renewing because people get bored online. People have the attention span of goldfish, and context specific, right? If it's a soccer site or a news site, I'll be showing different content because the audience is different, right? I'm assuming they're older, younger, more focused, less focused, whatever. Right, so the first stage is I approach the website. I'm looking for the soccer game. And me, as ARPLI, I have to figure out what the context is. What colors are here? So I'll pick an ad that matches the background. What kind of user I expect. And the amazing thing is there is now a tool called VQA, which means video? Oh, there we go. This is a website called Bouncing Cats, okay? And when you put it into the VQA and you ask it a question, it can tell you. The primary colors are green and white. There's a lot of open space. The demographics is people who like silly cats and humor. Or actually, that's backwards. Cats and silly humor, which is great because I can figure out what kind of ads I should be showing. Okay, so take a picture, ask questions, get context. Then I'll take the inventory. In this case, I want to be selling M&Ms. And because I mentioned that I want to be constantly improving, so I'll also take whatever ad worked yesterday. In this case, melts in your mouth, not in your hand. Not that I invented it, but it's a pretty good ad. I take all these, and we put them into an LLM. Okay? And LLMs, again, for those who haven't been online for the past few years, it's a system where you take text, you put it into a computer, and you get either text or images. Okay, so I can say, draw me a cat, or in this case, draw me an M&M playing soccer with a background that fits the red thingy here. Okay, I haven't mentioned this yet, but all the images were created real time, like by our system. Okay, it's not like we didn't let our creative team actually draw them. The LLMs did this. Okay, so we have content generation, and it takes you 6 lines of code. Okay, this is boilerplate, and here you tell the computer what you want. Now this is for text generation, but for image generation, it's virtually the same thing. Okay, and what's amazing is these days the cloud providers give you managed databases, right? So you can run this from within the context of your code. you can run it from, if you have columns in your SQL, you can run it as a column, and it'll fill out the rest, which means 0 boilerplate on either side, 6 lines of code, yay for us. The next stage, OK, so how much is it worth, right? If we roll back to the beginning, we want a lot of content. We have lots of different ads. And now we have to figure out how much to bid, right? We have our art, how much it's worth, which is this stage, OK? And we've used 6 lines of code so far. So obviously, we're going to figure out some kind of regression, right? We're going to take the content and the user and what we know about them and other things and we're going to figure out how much it's worth. So we're going to take, the website and, the device, the user device, where they are in the world, and in this case, the chocolate bar we're going to sell. OK? Now, again, unfortunately, the internet is a mess, and it's not so easy. Specifically, we have over 250 different apps a day, over 500 million different URLs, and hundreds of different devices. So if we wanted a separate regression for each one of them, it would take forever, right? So we'll need to generalize. But amazingly, we have another cool tool that helps, and in the field of generalization. It's called embedding, right? We take, in this case, a magazine, but all these magazines have websites, so as far as I'm concerned, it's the same. We take the website and we turn it into a point in 3D space. Now, amazingly, if I do this for all the points, I can cluster them. And I can say these go together. And then I can organize my websites, right? And then instead of trying to learn a different regression for each different one, I can drastically reduce the cardinality of my space. And then I can make regressions much faster, OK? And this whole thing now, OK, and this is also built on the LLM technology, where if in the beginning I would give a text prompt to the computer and get text or an image, here I'm reversing the direction and taking text or an image, because we're using multimodal models, and get a vector from the other end, OK, which is the point in 3D space. And this whole thing, again, takes 6 lines of code, because boilerplate, and the query here is whatever context you want to figure out, right? So, and then once you have the points, clustering them is another 6 lines of code, which is a lot of fun. Free to take pictures, but this is all in the blog post, so all the examples are there. And like I said, this is like BigQuery, but AWS. BigQuery is Google's, but AWS, or the other ones, they have similar ones. Great. So now I've reduced the dimensionality of my code, of my space, right? And I'm still trying to figure out how much I should be offering for different ads, right? I have different placements. I want to go back and make a model. OK, so now instead of the website, I have the embedding of the website, which is drastically smaller in dimensions. I have the device. I have the place in the world, the candy. And I'm trying to figure out how much money I should be putting here. OK, now luckily, since I already have it in the database, in order to get the embedding, right, I have a column that's the information about the website, a column that's the information of, and so forth, right? These are all features. I just tell the cloud platform, make me a model, OK? Now, what's amazing is this can be deep neural networks. This can be logistic regression. This can be trees, anything. It doesn't matter. Like I said, questions at the end. I'll answer them all. Now, this is great, because this gives me how much the different ones are worth. But we live in a world that's constantly changing. It's seasonal. It's cyclical. People are worth more, like ads are worth more or less in the morning, around the holidays, because they're buying stuff, Black Friday, and so forth. And so we would like time series, right? We would like to figure out if an ad was worth $5 in the morning, how much it's worth at 9 in the morning, and then 10 in the morning, OK? And these are also covered, built in by the databases. You just tell them, build me in this case, an ARIMA model. But it's the same. They have them all off the shelf. Once you put your data in the database, it's there. So we're up to 29 lines of code. And we have content and how much it's worth, or how much we should be bidding on different ads. Great. So how do we handle new content, right? We have the content. We know how much to bid. But the creative team says, this is an amazing ad for Christmas. Or we have an idea because we see that lots of young people are eating your candy. We should make, or in this case, old people, because who knows who Mr. Bean is. But So we have new content, right? And we want to know when to show it. Specifically, we have this problem. We have old content and we have new content, and we have to try to figure out when and where and whatever, right? Specifically, we need to know, should we be giving a chance to the new content? How many chances we should be giving if it fails miserably on the first time we show it? And should we be showing it on different websites or all the websites or specific websites? Where are we trying our new content? Now, luckily, there's a whole academic field around this. It's called MultiArm Bandits. And there's a PyData talk from 2 years ago with Uli Golan, who gives a very thorough discussion of this. And I'm not going to reinvent the wheel here in a talk about reinventing the wheel. So what I will say is how you can adjust the pipeline we've already built, okay, to the use case, okay? How we can, by making minor tweaks, how we can get a lot of the juice of, or the effect of a multi-arm bandit. So, to introduce you guys to the world of multi-arm bandits, right? You arrive to a new city, and there's lots of different restaurants, and you have to figure out which restaurants you want to eat at, okay? Now, you could, because we're all data scientists, right? So you could build a model and tell it, you know, this is Italian, and this is how much I like the meal. Now, there's a problem here, okay? Because you might have gone to a restaurant once and had an awful meal because the chef was sick and they brought in some replacement. And then from here on out, the model will always tell you it's an awful restaurant, right? Which is unfortunate because you might be missing out on a great place, or you might get stuck in a good place, but not a good enough place, and so forth. So one thing you can do is A/B testing, right? You could say, the first month I'm trying everything. Another common approach in multi-arm bandits is epsilon greedy, saying a certain % of the time I'm going to randomize and just go anywhere, which is also great, but you keep on going to bad places over and over again because they come out of the random selection, okay? And here at RPLI, we did something a little more dynamic. To figure out how it works, let's go back to the problem with the multi-arm bandit, okay? When I ask my model what you think of the restaurant or a certain ad, it gives me one number, right? I say, how good is the ad? It says 9.5. But I have no idea if the 9.5 is based on one meal at the restaurant or 100, if it's sure, if it's not, if it's sure but only for, you know, sports websites. So instead, we're going to go to models that give us back uncertainty. So in this example, let's pretend that I went once to McDonald's and it was because for some reason I had a salad there. And I went to Domino's a lot of times, so I'm a little more sure, right? The probability distribution is a little more tight, right? I'm more sure about my rank for it. Now, Domino's could be better. McDonald's could be better. And this thing shows me that I think McDonald's isn't as good, but it might be better at some point. And if my model gives me back a probability distribution instead of a single point, I can do fun things, like say, let's compare the 95th percentile, which in this case, what it will do is it will force me to go to McDonald's a few times, right? And then this will either get narrow around the middle, and I'll figure out that Domino's is amazing, or it'll narrow down ahead of Domino's, and then I'll go to McDonald's, which is great. In general, this takes into account not only what I think of a place, but how much potential there still is there. Another thing I can do, which is called Thompson sampling, is randomize, like select random points on the curve, and then as long as there is some kind of chance that one restaurant is better than the other, I'll find myself going there. Okay, and in our case, this is ads, right? So this one is an ad, and the blue one is an ad, and I'm trying to figure out when I should keep on giving chances for the red one, right? If the red is the new content, so until the distribution narrows, I'll keep on giving it chances. And when I said I'm going to talk about it only insofar as I want to figure out what I can do to my to my existing pipeline. So most of the models, they can give you some kind of measure of uncertainty, their standard deviation. If not, you can add some random noise, and then you get the standard deviation. And then what it means is you have content, you have value, and you have it without really changing your system at all. You have it for free, in quotes, which is fun. You get exploration out of the box. Great. One more line of code, and we're almost there. Monitoring and continuous improvement. So this is relatively simple. Right? We made the ads. We've bid on the ads using the regression. We've added new ads. And now we take all these loops, right? And all the providers have a database. Great. And most of them already have like a hooked up visualization platform. amazing. We can see when it's going well, when it's not so well, morning, evening, whatever. And we can do QA. We can figure out when it's working, right? We can have the system tell us if it's working. And this is another 4 lines of code, which once your data is in the database, you can ask it to find drifts automatically and find anomalies, right? And take your mind off things so you can go to the beach. So 4 lines of code, and our system tells us when it's not doing so well. The last feature is continuous improvement. So let's pretend I have this ad, and it's working amazingly, right? This sells crazy amounts of chocolate. OK, so I can ask for a variant of it. Now, if we're going back to LLMs, right, I can say there was this text that created this image, and I can give it variants. The same thing, but a little more red, or the same thing with a lollipop, or the same thing. And specifically, I can use genetic algorithms to combine good ideas and get different variants of content that's amazing. Another fun thing I can do is explore on context. So if I know that NASCAR readers really like chocolate, I can check what else is in that same environment, same area, and try to advertise there as well. Okay, so I know where my ads are working, and I already have everything embedded into 3D space. Let's look for neighbors. Great, so 4 more lines of code. We have drift detection, we have visualizations, we have genetic algorithms that consistently improve our content and where we're showing it. Let's take a brief overview of the system in general. Okay, so we've taught the AI, we've added the ability in our pipeline to generate content. We've added the ability to figure out how much an ad is worth and bid accurately. We know how to explore new content virtually out of the box. And we're constantly improving and measuring and figuring out when we're doing well. Now, again, these tools are cool. They're a lot of fun. But the point is not specifically ads or even specifically these tools. It's figuring out where you can offload the heavy work so you can focus on the real challenges. The creative department can figure out which cool new ideas they have and deploy them, right? So they don't have to reinvent this every single time. Specifically, using this kind of pipeline allows us to deploy things rapidly. One of the sections here was done in a day and a half of a hackathon and hooked into the system, and it's working really well. So we can test lots of different variants. If someone in the business department has an idea, we can test it within days as opposed to months. We're using tried and tested solutions. Okay, so you're using things that major companies built and rely on. They're safe. They work. You can put them up and continue on your way and go and focus on the other things. And as opposed to some crazy big monolith black box that's making decisions that you have no idea why or when or whatever, the various different components here can be tuned separately, right? So you can dive into the content generation or the exploration, each one separately, and you can tune it. You can put in new ideas very, very quickly because you know what each component is supposed to give you and what it starts from. In general, as like from the ARPLI angle, all these new tools allow you to focus on the fun stuff, on concocting the new flavors, right? On the real challenges, on the cutting edge solutions, right? Someone else already made these big tools. Use them. Focus on the fun stuff. Like I said, the details of the blog, code segments, articles that we read and based different parts of. I think there's also a link there to our LinkedIn and conversation page, also amazing. Personally, feel free to reach out if you have specific questions, what we did, why, if we missed something, let me know. And with that, questions?
Thank you for the talk. It's very interesting. I was very also super exciting about the content generation because it seems very new. And my question is, basically the content generation, if I understand, is mainly the LLM, and after maybe a little bit of genetic algorithm at the end.
Right. I mean, if you don't include the exploration segment, so it's LLMs, but LLMs have different use cases, right? We're using an LLM for the embedding. We're using an LLM. An LLM is also behind the scenes of the VQA and also behind the scenes of the actual content generation. And also behind the scenes, so I think LLMs are a major component here of the generation, the VQA, and the embedding.
Okay. So my question is, because when talking about image, I'm almost sure that you already heard this question is, why not using like a diffusion model, which are based specifically for image?
Right.
And then you can also condition the condition like the generation. But more of that, I think I never seen that this way of doing. You can also condition the diffusion model for optimizing, like for instance, the performance of the ad. You can directly generate an image that will provide like a crazy performance, theoretically speaking.
Okay, interesting. Actually, that's something I have to read about. In general, I'll catch you on the side. That's something I have to look into.
I have a question about this slide.
This one? Wow, that was lucky.
If you have a custom model that you're doing,
okay.
How easy is it to plug it into the BigQuery engine, and or are you forced to use like specific predefined models and what they provide?
So I'll make a general note and also your specific question. Like I said, everything here is BigQuery examples, but it's also the same in Python. You can wrap it in generic libraries that allow you to swap out the models for the diffusion case. So changing it is very, very easy. I mean, at the end of the day, you can always put it into some kind of airflow system and do most of the lifting and then actually swap out the model with something custom on the side. I don't think you can, I mean, technically you can give them a lambda Python expression for a column and figuring it that way, but I'm not sure if you can train the whole thing in those so it depends exactly what you want to do. For example, if you already have the model trained on the side, you can give the lambda and then it'll figure out the column values. I don't think you can do the training part of it built in. I mean, if you want to use a custom model.
And also a question about how do you test and explore and do research on different
Components?
Yeah, components.
So, I mean, sort of what I mentioned in the end of you have a bunch of different components, right? So you know what everyone's supposed to do. So we still have a creative department. Like I said, this isn't the be-all, end-all, a complete pipeline as most of the companies do. This is how to offload the key components. So we still have a creative department. They still do amazing work. Most of the amazing ideas still come from them, right? So one thing you can always do is just ask them how these things look and what they recommend, right? If you're talking not about the output, like the code output of a specific segment, but how it does in the field, like the A/B test, so you have to hook up the entire pipeline, right? You have to let the content generation run all the way through the exploration, which does some kind of optimization, but we have things in the system that run the whole loop. So, I mean, it depends on which component you want to isolate, right? Models are pretty easy to isolate, right? But you can always, you can have the feedback loop sort of similar to the exploration of just the value and the exploration. You can set up different loops. If you want it to be optimizing in the field, you can set up specific loops that do that. But you also get each component separately, right? So you can zoom in on them. Other questions? Yeah.
So regarding getting variations of the same prompt and same image,
right?
You were talking about genetic algorithm.
Mm-hmm.
So if you could elaborate on that topic,
sure.
And specifically, how do they compare to prompt optimizers like DSP1?
So one thing you can do fairly simply, right, is take a picture, ask the VQA what's in this picture, and then you'll get random variation just because the models are a little noisy, right? And then tell it to rebuild them, and you'll get lots of different variations. Then you can do things like tell it to make specific combinations, right? Take this picture and make it more red, make it more green, make it happier, make it sadder, because it's text, right? So you have a bucket list of things that you like, and you just tell it. Then you can start having them, interact with each other. You see one going well this way, you take the prompts from here and you pipe them into the base image from another one. So in general, you're just taking good additional prompts from some areas and looping it back into the system. It's like you have a mini feedback loop where you take the successful ones and you loop them back in.
And the success is measured by your model.
Yeah, it depends, right? Similar to the other question, I I can test the success in a model, the UAC, that kind of thing. Or I can say how well, as an A/B test, how well it performs, like how many clicks I actually get, right? What Moran mentioned, which is super important and one of the key fun aspects of ARPLI, you can change the model and you'll be showing ads and you'll know if it's good or not within an hour, right? Because we have an infinite stream almost of incoming requests, and we can test in the field what's working. We can have thousands of different mini A/B tests working. So you can also test offline, but you can also just run it in the field and optimize directly with the field as the target.
And regarding the parameter space, like colors, emotions, what you said before,
right?
Do you define it manually, or do you write a model?
We define it manually, but we can tweak it. So a bit of each. Yeah.
I was wondering about how you manage, first of all, AI at scale.
Okay.
For diffusion models, it takes a while to run, especially if you're running them for, obviously you don't need to run it for every request.
Right.
And then two, I was wondering about brand image. I know a lot of companies are really concerned about how their brand looks. Have a lot of content moderation and that kind of stuff.
Right.
How do you kind of justify to your customers or people that might be interested in using ARPLI to say, like, hey, we're not going to mess with your brand image. You can trust us to show the customers what they need to see.
And I'll take those separately. So one of the key reasons to work in this kind of system is that you're taking tools built by mega corporations built to work at scale, right? It's almost a built-in part of the pipeline, right? In addition, you can prioritize fairly simply, right? You have CNN, for example. You have tons of different hits there, so you build a queue, right? And you say these ones are the first and most important, and I'll optimize there. And if at the end of the day I have compute left over, I'll try to figure out all the other ones at the end. As far as brand image, it's part of what we do. There's obviously long-term relationships between the advertisers and the companies working for them. One of the things that are most important to us is maintaining those relationships because like you said, we're representing them online, and we're making millisecond decisions. So far, it's gone pretty well.
You use your system to optimize CTR?
Okay, so there's lots of different ways you can do it, right? If the person clicks but doesn't convert, so number one, you might have a lot of fraud, right? You can have random bots pumping up and messing with your models. You can have people who really clicked but weren't really interested in the product. So ideally, if you had enough information, you want to train your models as deep in the funnel as possible, but you can't always. So it's a balancing act of what you know and what you can know.
My question is, one, can you optimize it can you use it to optimize LTV and ROAS, not only CTR? And the second
We do.
question is, how do we tackle the bias of users who see your ad but then go directly to the website instead of clicking?
So the first one is yes, we do. Sorry. The first one is yes, we optimize ROAS, LTV. It depends on the relationship, company, and so forth. It's more on the business side. And remind me of the second part?
Users who see your ad but then go directly to the website.
Right. Okay. So in general, cookies. But it depends on the deal. Look, there are websites. If you go back to the real Mad Men days, right? Someone saw a commercial on TV and they didn't even have a trail back. So part of the details you close with the company that you represent is what's considered yours and what's theirs, and if cookie says that they saw your ad a week ago, if it's yours or not. Somewhere in that field. Shoot.
Just sign up, it's more convenient. Do you always check with human validation the generated creative? Sometimes when you take another variant, the text comes up a little gibberish or... Yeah,
for sure. At the current stage of AI development, we always test, someone looks at them before they go online.
And in which part do you take consideration into the targeting? Because you maybe have an offer or an ad that's maybe a good ad to show to someone, but the advertiser don't want to show it to specific people. That's the targeting. For example, like the visitor is 10 years old.
Right. So it goes into two directions. In general, the advertiser wants to convert, right? So if you give him someone, it's similar to the previous question. If I'm optimizing revenue, right? So maybe they think they don't want. If it's a legal issue, then they can tell us, don't bring these people, and we can comply, as far as we know, right? Because it's the internet. But number one, they could tell you, we think we should be targeting, middle-aged men in Middle America, and our system can say they're wrong, and then you can discuss it with them if they're very sure what they want. It's a different story. But in general, they have the same target as you do, right? They want to maximize revenue, and you want to help them maximize revenue. And as long as that's a KPI that you can see, you handle it. Anything else? Last one?
This is the last one. Let's take it offline.
How do you know if the embedding is good and the clusters are good?
So in general, number one, you can always validate by eye, right? I mean, you put a bunch in, you see what the clusters are, and you say, wow, that's more or less what I would do. But secondly, I mean, there's a lot of systems. You can see how many dimensions it finds. You can, we have a test system where if we change the algorithm, we put the same thing in, and we expect the same thing out. Lots of different.
How do you know if they are actually should be clustered? If that's the
So like I mentioned with the previous question, at the end of the day, because we're a company that streams online data, most things you could test offline, but you can also just test them online and see if a model based on those clusters is better, and then you're fine. We're done? Like I said, I'll be walking around, so if anyone has other questions, implementation, theoretical, I'm Ronny, by the way. I'm here. ¿Me puedo?